All right, so now that we kind of understand the naming, we do want to make sure that when we have parallel lines in a transversal, which is exactly what we're going to go to in this next problem, we still have the same relationships as if they weren't parallel. I shouldn't say relationships, the same names as if they weren't parallel, but the relationships are a little bit different. So for alternate interior angles, we have alternate sides of the transversal and interior of the parallels. So we can actually see that over here. And I know if you're looking at your notes page, it's all kind of black and white. We don't have colored notes pages, which would be nice. But this is kind of the intention of this one, but it's kind of nice because it's only showing the one. So I did here's the top left one and the bottom right one. So it's on alternate sides, which alternate means different. Different sides of the transversal and interior of the parallels. So it's inside the parallels. And the relationship, so I'll have you write relationship. Ooh, I should have given us more room there, right? Relationship, which just means, when I have these patterns, what happens? So if I have parallel lines in transversal and the angles are on different sides of the transversal and both inside, so they're on different sides, but they're both in between the parallel lines, see, in between here, then they are congruent. So this is the congruent symbol. It's an equal sign with a little kind of whoopee above it, like that, like a little wiggly line. So this means congruent. So I'll put this a little closer even, just so that we can kind of see this. So these are congruent. And then when we have same side interior angles, so same side, I don't think we need another word for same side. They're on the same side of the transversal, and they're both inside of the parallel lines. Again, interior. So we're looking in between the parallel lines like this, but now instead of going to alternate sides of the transversal, we're on the same side. So these do not have the same relationship. They're not congruent. They are supplementary. Supplementary, which means they add up to 180 degrees. So that's definitely a big one. We want to make sure we understand that relationship there. All right, the next one we have alternate exterior angles. So alternate, again, still means different or opposite. I guess you could think of it like that. So different sides of the transversal again. So now we have one on the right and one on the left of the transversal. And exterior of the parallels. So this means outside. So if this is inside like this is interior, then outside means that we're going to be outside here like this. Okay, so we can see this one is definitely outside, this one's outside, and they're on different sides of that transversal. This one's on the right, this one's on the left. Okay, so when we have alternate exterior angles, those go back to that congruent relationship. And then we have one last one here. We have same side, I guess I'll do it in this light green, same side of the transversal. Again, I don't think I need an alternate word for same side. And they're both exterior of the parallel, so they're outside. So we still have outside here. So I can definitely see these are both outside the parallel lines. They're not in between them. But now they're both on the same side of the transversal. We're not on alternate sides. We're both on the left side there. So these again are supplementary. And one other thing they don't put on this little notes page, which I'll have to add to the other notes page here just to make sure that we have it, are called corresponding angles. Corresponding angles. That one's an important one, mainly because it's, another piece of congruency. So corresponding angles are congruent. And to find a corresponding angle, it's almost like if you could take the angle and just scooch it down until it fit right into that other piece. So it almost looks like I take this one and kind of scooch it down, or I could take this one and kind of scooch it up like that. But it's kind of like sliding the angle back and forth. Those are corresponding angles. And we can say they're in the same relative position. What that means is if I look at this one here, it's below this parallel line and to the left of the transversal. So I'd want to go to the other parallel line and go below it and to the left, and that's my corresponding angle. So I can describe it in the same way. That's what same relative position means, based on its parallel line. So that's another really big one that we use pretty often during these proofs when we're going through and doing the two parallel lines and a transversal. Right. So with this one, we're trying to prove that line A is parallel to line B. So now we're trying to prove that the lines are parallel. So we're actually kind of going backwards a little bit. Before we were given parallel lines, so all of these angle relationships worked. Now we're going to look at the angle relationships and say, as long as the angle relationship is there, the lines are parallel. So we're kind of starting backwards from what we just did. And that's because there's these two sections mixed together. So the first section shows us how to go forward, and the second section kind of shows us how to go backwards with the converse here. So we're given that angle 7 is congruent to angle 5. So we can send that guy to proof. We were given that. Angle 7 and angle 5 are corresponding angles. So let's see. For this guy, we're going to reference the corresponding angles. Kind of flip forward here. I think we can actually just jump straight from, I believe we can actually, let's see. So if we have corresponding angles are congruent, which we do, 7 and 5 are corresponding angles and they're congruent, then the lines are parallel. So we're actually, this is one of the pieces we were given, and I know we have a whole lot of theorems and postulates and definitions, and we have quite a few different things going on right now, but this was kind of the backwards. We were given if parallel lines are congruent, if parallel lines are crossed by a transversal, corresponding angles are congruent. Well, the opposite is also true. If corresponding angles are congruent, then the lines are parallel. So we're just kind of going backwards from that, so we can actually, oh, darn it, I got rid of it. Send it to proof, and corresponding angles. So I believe we can validate and that'll be done. Yay! So it's only a two-step piece there. We had the given and we have one statement. The given was enough to say, yep, just with that given alone, I can prove this statement. So we'll do one more of these. Oh, darn it. I actually wanted to go to number 7. That's what I meant by one more of those. Because number 7 should be a little bit longer if I remember correctly. Okay. So let's go ahead and take a look at this guy. So we're going to try to prove that BA is parallel to CE. So we want to prove that these two lines are parallel to each other. And we're given that BC is parallel to FD. So we know that these two are parallel. And we're also given, and I guess I can keep this in pink since it's an angle, that angle 1 and angle 4 are congruent. So let's go ahead and send that to proof real quick. And let's see what we can do with this. So we want to show, and we can kind of think of this as extending outward, just so that we can kind of have that inside-outside idea. So I want to get from what I have to kind of something that I can compare here. So I have angle 1 and angle 2. Those are probably going to be my two angles that I'm going to use here, because angle 2 is kind of attached to this guy here if I extend it up, and angle 1 is attached to this guy here if I extend it down. So if I can prove that these two angles are the same or congruent, then those are alternate interior angles. So that would show that those two lines are parallel. So I need to try to move in and prove something here. So if I use angle 4, and I'm looking at this guy as the transversal for a moment. So angle 4 and angle 2 those are alternate interior angles. Because they're in between the two parallel lines I already know about, the BC and FD, and they're on opposite sides. So I can go here and I can say angle, I don't know if I can use that, I have to click on angle. Angle 4 is congruent, and we don't want to say equal because we're talking about the angle in general, not the actual angle measure. So just be careful with that. It's, the difference between the two pieces. So angle 4 is going to be congruent to angle 2. And my reason there is alternate interior angles. If line is parallel, alternate interior angles are congruent. So I have to choose that statement. So perfect, it'll let me do that. So now I've moved over here. 4 is congruent to 2. So, and this even says you may use the transitive property for equal or congruent. So it's talking about transitive property. You can't use it for parallel lines, but you can use it for the angles. So I can't say if this one's parallel to this one, it's parallel to this one. I can't use it for the parallel lines, but I can use it for the equal or congruent. And so if I look at this one, it's kind of a step actually. 1 to 4, 4 to 2. This is a perfect example of transitive property. What I do is I kind of cross off the 4 a little bit, and I wish I could actually mark on this page, but I ignore the 4 and I go from 1 to 2. So I can go, the measure, or angle 1 is congruent to angle 2, and that's by transitive property. So I can make that jump using the transitive property. It looks a lot like substitution, so which actually could very well, I think that would also have worked if I used substitution because it was only one jump, so that could also have been substitution. So now I have angle 1 equaling angle 2, which is what I wanted. So now I think we can go ahead and try this. We're going to send a proof. The two lines have to be parallel because alternate interior angles are congruent. So if I go down here and I say, if alternate interior angles are congruent, then the lines are parallel. So I'm going to validate, and I think we're good. Yay, the proof is complete. So we can go and check. Once you get to that point, it's good to go. You're going to get green. Make sure you click the check button so you get the green check mark, because otherwise it doesn't give you the point for it, which I know seems a little silly, but you need that little green check mark to kind of be done with it.